Hi there, welcome to another version of the electric BMW 320i project. No, I'm not up in the Great White North, but that's where I was when I got these souvenirs, crutches and a brace. I had a really nasty crash on my skis and had a little fracture in my tibia, so now I'm on crutches for at least another 3 weeks and then some physical therapy. And this kind of limits me doing some work on my car, certainly no physical things, and I'm not going to get around any batteries with these nice big aluminum conductors, but I can still do some work on electronics and low voltage things, and that's what I'll be showing you this week. I also got the Siemens adapter finally put together, and looking forward to getting that back in the car, so let's take a look. Here's something I've been working on while I've been laid up on my crutches. This is the now second version of the BMS, or battery monitoring system. It's designed to monitor 4 segments of the battery voltage and 4 temperatures of those battery segments. It has these chips that are a combination of an opto-isolator and MOSFET built right into one package for isolating the battery segments, and then there's a group of MOSFETs that are in the corner here where they're used for isolating the thyristors, and then a set of isolation chips that isolate the I2C and the CAN bus from the outside world. The analog to digital is 16-bit, and it uses the same kind of hardening that we've used on the JevQ, as well as the same SAM Cortex processor that we use on the JevQ. You can see it makes use of this cinch connector. It's just a little different than our JevQ, and the connector for that is different than the amp seal by similar. It has the same kind of gasket interior and has a double crimp type of pin. Let's see here. That crimp's similar, but still needs a little bit different die. And this is designed to communicate via CAN bus and get the measurements of all the voltages and temperatures. Here's something else I worked on while I've been laid up. This is the main contactor box for my car system. You see in the middle there is a big resistor. That's the pre-charge resistor for the DMOC, and this has 3 main contactors, and it's designed to be able to pre-charge the DMOC and also be able to completely isolate the pack from the rest of the system. It has an amp seal connector on the end to bring in the signals for controlling the relays, and a set of 12-volt relays on the side here. I'll show you this picture here. This shows the mock-up I did inside the car and how everything goes together and how it's going to be connected. So that's the next stage, is to get this actually mounted in the car and finish up the wiring. Here's something I never thought I'd have to do, is give my Leaf a 12-volt jump start. The car's been sitting here in the garage for about 3.5 weeks, and I just went to move it and discovered it was totally dead. Now that's kind of weird because I fully charged it 3 weeks ago. It should have plenty of power in it, but it turns out the 12-volt battery is what controls everything. And it sort of makes sense why it might discharge over that time, because I know the Leaf has to have some kind of cellular connection going all the time, because it's possible with an iPhone app to connect to the car and turn on, you know, like the charging, or turn the heater on or the air conditioning on. So that's got to be using up some power plus something else. So apparently what Nissan does is they run everything off that 12-volt battery, and if it dies, you can't make the contactor for the 400-volt battery and charge it, so you have to charge it in like I'm doing now. Very interesting, but actually kind of smart, I think, because it could be a way to protect your 400-volt battery pack from being fully discharged, is to run everything off the 12-volt and only have the 400-volt connected when the car is on and the contactor's made. It's a lot easier to charge up that 12-volt battery than a 400 volt battery pack that's been discharged down to about 1 volt per cell. You can see it's pretty badly discharged. It's drawing a full 10 amps off the charger. So we'll let that run for maybe a half an hour and see if I can get the leaf to turn on. Here's one of the cool accessories I got. This car didn't start out with this badge on it for designating what it is, a 320i. They actually had this on the real OEM website for BMW parts. I'll show you this here. It's amazing they have so many parts still available, original equipment. It's interesting that the 320i, the I is separate. It's not part of the main 320 because the this car came as both a 320 and a 320i. But one of the things I thought of on this was taking the idea that BMW is doing with the i3, is that maybe I can do this. Make it a i320. And I could even maybe get the big I that they use on the i3. It's about twice as big as that I. Although I do plan to, or I had planned to put one of Jack's electric scripts on the back here. So maybe just leave it 320i and leave this here as a electric, and people will get the idea. Although the badge E-Drive is also available from BMW, but well, just have to think about it, see which looks best in the back of the car. So here's something else I got done. I finally got the flywheel attached to the spline adapter, and what I had to do is this rebirth adapter had to be machined on the face of the flywheel side about 150 thousandths off to make clearance for the flywheel to turn. And that, I reckon, is because they never actually had the original spline engaged far enough. They had it sticking out far enough so that the flywheel had clearance, but that meant that the spline wasn't in far enough engaging the spline. So now with the new spline adapter from EV West that fully engages the spline, that obviously doesn't stick out as far much, so then the rebirth adapter had to be machined to make clearance for the flywheel. So next thing to do is put the clutch on, and then after I get off my crutches, be able to put the engine back into the car. Okay, so you can see some things going on. I'm still able to put electronics together, and well, we'll see how well everything else goes together. Next thing I'll be working on is the whole package for the instrument cluster. You remember a few videos ago I showed how I was able to drive all the gauges by pulse width modulation. Well, I had planned to build a circuit, but I didn't know how long that was going to take, so that's going to be my next endeavor, and maybe we'll get to see that in an upcoming video. But thank you for watching, and we'll see you next time. Bye.